Next topic we are going to see is the structure and union, and these are the function which can be defined by user. So this is user defined function. User defined data types. So this is the syntax of the structure and same union. So first we have to define one name, structure name, and for that we have to write struct and open brace, close brace with semicolon, and we are declaring some of the variables. So it's kind of array. Array means collective collection of same data. So array is collection of same data, but if you want to access a different data type with the same name, we have to use structure or union. So inside student you have declared character, integer, float with a different name. So here you can see character name 50, which means that it is a 50 character inside that. So this is the array. So 50 character inside that name, which means that A, B, C, D kind of that. So each A is one array, B is one array, but A, B, C, D, everything will be the same data type. So that is called array. But inside that structure, we have a different data types, and same as in union, we are naming that as a data, and yeah, here also we have a different data types in different names. So inside main function, first we need to declare the structure and union inside that. So structure, so the structure name is student. For our usage, we are changing that structure name into some other variable, student one. So same as union data and data one. So the basic difference between structure and union is that structure will hold the address for each and every variable, but union will uh, hold the largest data type value. So in previous program we saw that how much character or integer or float will carry, right? So as same as structure will hold the total number of addition of all the data types. So character plus character size and plus integer size plus float size. So when it comes to union, it will only hold the biggest data type, like that a float have a 8 byte means, so it will only hold the 8 byte. So it will not have a more memory space, but there is a restriction in that. Why we need to use structure and union means inside structure we can access all the data and all the values in a same time, and we can manipulate and everything. But inside, if you use a union, you can use only one variable at a time. So again you have to, inside union you can only access the one variable at a time. If you want to access another variable, again you have to change the variable name, change the variable type inside the union. So this is how it will work. So first what we are doing is that we are directly printing the size of the structure, and then we are printing the size of union. Then now we are doing the uh, we are storing the values inside the structure. So here we have a yes and printf. So what this function will do is that, so this is the uh, structure to call the structure name. So first we need to write the structure name which we declare, then dot name. Name means inside structure you may declare the variable name. So here we have declared that, then comma size of student one number, which means that it will only give the name data types size. Then we are storing that this uh, string message inside C. If you want to access a string message, you have to only store that by character. So to store or access the string message means collective of character. So if you want to do that, then you have to do the sn printf. Here, what sn printf will do means, so whatever here you have written, so it will store that inside this function. So you can store character without using that like this, but you can't like student dot name equal to a. So if you write like that, you can directly uh, store the character value inside that name. But if you want to store the string message, then you have to use the sn printf. Then only it will store. Then we are storing the integer value, as you can see, the structure name and the data type integer name, variable name, then the value. Then we are storing the student, then same float value we have stored. So here we are calling the union data type name. Then first value of union data. Then we are storing that as an integer. So first three we are printing the values uh, of structure. Then we are printing that value. Here we are directly printing the data one int value. Again, actually, like this, we can't store like this. Here, it's a structure storage. We can't do same like this for the union. Whatever you do that, so it will only print the last stored value if you access the union data type. So that's why we are doing separate by separate. Save data into value 42. So now that will print. Again, what we are doing is that we are accessing the same union data type. Again, we are storing that float value inside that union. Then again, we are printing. So as you can see, you are doing the percentage %d and percentage %2f. So you did it. But after that, you are trying to print the data one int value, which means that here you return that 42 and here you are trying to print that. If you print that, it will give a unexpected result, so which we run now. You can see. So now you can see the output. So if you come into that first printf, so this is the size of structure. So it is printing as 60 bytes. So now you wonder why it is coming. So integer is 8 byte, sorry 4 byte, and here float is 8 byte. Then the size of float will be 4 byte, and here the character is, each character consists of 1 byte, so 50 character means it's a 50 byte. And one more thing you are seeing is that here it's a total is 58, but it is coming as a 60 byte. So why it is coming as a 60 byte means, so sometimes when you declare a structure, the compiler automatically do the structure padding, which means that structure padding means that inside the compiler, when it store the structure, it will do automatic padding like a even number kind of thing. So that's why it is automatically took that as a 60 byte. So why it is coming means, so character is a 1 byte. So first 50 byte will be stored in the register memory map. Then integer will be 4 byte. So 54 byte. Again, if you want to access a character in between, again that one character space will be stored, and again float 4 byte will be needed. Then 1 byte it is storing. So whatever how many data types you are typing, so it will add to 1, because the first data type is character. So the structure padding is a different concept. That's why it is doing for compiler reading reliability kind of things, it will automatically do the structure padding. And when it comes to union, it has a only 4 byte, because float have a 4 byte. So integer and float have a 4 byte. So compared to character, float has a bigger memory size. That's why it have a 4 byte. That. Then we are printing the student name. So as you can see, um, here student 1, so alias, student age, and CGPA. Then we are printing the union value. So first value 42, so 42 it came correctly. Then we are storing float value, so we are storing 3.4, so we stored. Again we are trying to access the int value. Then you can see we have a after setting the float value, we are trying to print the integer value. So it is giving some unexpected result or kind of junk values. So why it is coming means inside in union, one by one only we can access. So the last stored value inside the union is float value. So as you can see, it's a float value. But you are trying to print the int value as a percentage d. That's why it is printing like that. So that's the difference between union and structure. So again you can do that if you want to print that integer. Again you have to call the function and change the function. So if you can run, it will come. So now you can see the perfect data. So this is how you can access. So one by one only you can access the union. So why it is needed means in the inside the embedded system we have a very limited memory option. So if you go with kind of bigger program, it will consume lot of memory. In that case, if you want to access all data types for let's say that you connected one sensor, so that sensor will give us three parameters like x, y, z. So that we have created as a structure. Then again you have created as a union. If you created as a xyz, so as per the structure padding it will take 12 byte. So if you create declare that as a union, it will only take a 4 byte. So when it will differ means if you want to access or if you want to manipulate xyz at the same time, so you need, or if you want to access xyz, let's say that sensor is reading xyz value, you are storing that xyz value inside the structure. Then you have to take the value xyz full value, then you can take it. But in that case, if you use a union, the first time union will take the sensor value xyz, then you can only access a x value. You can't access a y value and z value, because again you have to call the sensor and again you have to take the data. Again that union has to store the data. Then only you can access a y value. So that's why sometimes you don't need to take all the, let's say that you have a temperature sensor. So temperature sensor will give a temperature and humidity. So one time you may need to read only temperature. One time you may need only humidity. So that time you don't need to declare that sensor data type as a structure to reduce memory. Thing you can use that union. So it's according to our program and according to our styles, according to our need, that two things may change. So this is the difference between structure and union.